Good morning. Welcome to the latest webinar that we're doing here at Knick, titled Why Should I Automate My pH Loop? So really appreciate everyone in the audience taking time this morning. We're going to cover quite a few topics here. Just like the invitation that you saw, we're going to discuss things such as reduced cost, operator safety, product quality, and sustainability, among some other things. But I want to go ahead and introduce everyone. Across from me is Joe Hirth, and he is primarily on the inside of our organization, supporting our outside sales and our customers when it comes to automated systems. Joe, describe a little bit what you do for us here at Knick.
What I do is I help with quoting and specifications on automated systems, sample panels, custom solutions, more of an engineered type products, as opposed to a day-to-day, hey, I need a handful of sensors. So I'm more of the long-term engineering.
Fantastic.
I need more questions answered.
Yep, there we go.
There you go.
And behind the camera, Seth Robinson, of course, you can't see him, but he's going to be helping us with moving the cameras. And at the end of our presentation, we're going to take questions from the audience. So he'll be the one to feed us those questions so we can get those answered for you as well. So again, thank you for taking the time. So the question again, why should I automate my pH loop? And when we ask that question, or when that question is asked, what we're referring to are primarily static pH loops. Okay, and just a quick education for anyone who's not maybe fully aware of what a static pH loop is. Essentially, it's a online or inline installation to a process where you've got a pH sensor and a static holder running back to a field transmitter, of course, making a measurement and then sending that signal back to your control system. For many applications, that static pH loop, as we call it, is more than adequate to make measurements for many customers. But there are applications out there that we run into quite frequently that require something more than just a static installation. And that's why we're going to talk about automation relative or relating to a pH measurement. So before we get into some of the topics, what we want to do is we want to use this as a visual aid. This is an example of a fully automated system. We call this our C-Care system. And I'm just going to give you a quick tour of what this really is showing you. I'm going to start with the outside bottles here. This is where we would hold cleaning solution, calibration solution, because this system is fully automated for cleaning and calibration. So right here, we have the controller, which is an electro-pneumatic type system. So we bring in power to it from the transmitter. We bring in air because it's pneumatically operated. And then, of course, the transmitter will send signals based on a program back to the controller so it can follow the sequence and the proper timing to go to this device right here, which is where I'll let Joe kind of show a little bit, but this is our retractable assembly.
Yeah, what we have here is our sensor gate retractable assembly, pneumatically operated. So you need air to move the probe in and out. Since we're looking at a pharmaceutical system here, we have a 2-inch sanitary clamp process connection. Process connections can also be threaded or flange connections. And you're also looking at the media hose, which feeds back to the controller. That feeds all of the pneumatic hoses, electric, liquid hoses, all that comes through in one nice tubing here. And then the other is a drain pipe to drain out all your fluids that you're using.
Yeah, so just a high level tour, as we said. Now, the idea behind this particular configuration and most automated systems we provide, if not all the automation that we provide for pH, this is designed to retract that electrode from the process without interrupting the flow of the process. So this is one of the big advantages using isolation through the retractable assembly. So all the maintenance that you want to do to the electrode is done inside the holder, as Joe indicated, but process is still flowing. So again, just give everyone kind of a baseline of what automation looks like. So With that said, Joe, what kind of questions have you been asked by customers before?
Well, let's get right to it, Ron.
Okay.
What's the primary benefit of automating an industrial process, let's say a pH measurement?
Yeah. So the answer is a little bit more nuanced than just here's what a customer wants, because each customer is looking for something different. Their particular process requirements will differ from plant to plant, application to application. So for instance, some customers, when they look to automate a pH probe or a pH loop, I should say, let's say safety is their biggest concern, because in the static example that we talked about, where you're removing the pH probe, you're having to isolate the line, drain the line, then you're accessing that particular pH electrode. So you're being exposed, right? Whether it be high temperature or residual process, things of that nature. So by looking at automation, because we're able to retract that electrode and clean it, evacuate through the drain that Joe mentioned, that probe is now safe to handle. So now the person who's going to do the probe replacement, let's say, they can remove that probe easily. It's not going to be contaminated. They'll be able to put a new probe in when that time comes and then put it right back into service. So that's one example. Another example, which is very common as well, is we have a lot of customers that are trying to reduce cost. That's, of course, everyone these days is trying to reduce cost. But in an industrial environment, when you have a static installation and it's a very difficult measurement in the sense that it's hard on the electrode, and this is an example of an electrode that we have here that goes inside this retractable, if you're not regularly cleaning that probe or doing what's necessary to maintain it, and it's not because you're actively ignoring it, it's just there's a lot going on in that industrial environment and you're trying to take care of things, those probes will not last as long as they could if you did have a way to automatically clean it on a regular schedule. So again, it's going to vary based on what the customer's individual requirements are.
Will that improve product quality? I mean, let's touch on a little bit on the quality.
Yeah, so there are a lot of industries. We'll talk about pharmaceutical for a minute. Fermentation reactors, highly sensitive to pH. So if you have an automated system where you're able to calibrate on a regular interval, but more importantly, very repeatable and precise calibrations. And why I mention that is, again, we're all busy. And in that industrial environment, if you have a static loop and then you're going to physically pull that electrode out, you're going to do a manual calibration, of course, putting in your calibration solution. Let's say it's a buffer 4 or buffer 7 and a buffer 4. You may be rushed a little bit for one reason or another, right? So when you go to put that electrode back in the process, is that calibration as accurate as you could have gotten it? Maybe not. When you automate it, those calibrations are the same every time. They're very precise. So that leads to, back, Joe, to your question about product quality. So now, if you do have a very sensitive process, pH is a critical measurement for that process. I think I mentioned fermentation. Now what's going to happen is you're going to get the proper throughput of the process that you're trying to monitor or trying to manufacture. You're not going to have to recirculate in certain cases to dose to try to bring it to within specification. So what that does is it, again, increases product quality.
So you're kind of saying, if you look at it from two different perspectives, you can save cost, operational cost, and then you also have costs that are saved in better quality or actually increased profits from having a better quality product in the long run.
Exactly. And another component of that is we see situations where customers have bottlenecks. So they've got their existing plant footprint, they've got their reactors, their processes, and there's not an opportunity to expand that. So what they can do is they can look at ways to automate certain aspects of the process, in this case, pH, where we can help them shorten the turnaround time depending on what type of process, continuous versus, say, batch. We can shorten the turnaround time for some of those maintenance-related issues when it comes to static pH. So what that, of course, translates into, I know it's the old time is money, correct? By shortening the time, we can help them increase throughput increase their own profitability, but without having to necessarily do an expansion right away to get those same potential profits, again, by using an automated system.
Good. Operational costs, right? We can save money on using less probes.
Yeah.
Less chemicals that we want to, put into our process. Is there anything else you can think of from operating costs?
Yeah, I mean, again, the probe, which is clearly something that's a consumable, because pH probes have a lifespan, a finite life. So of course, you're going to use that up as it's going through its day-to-day measurements. But then there's the other aspects of operational costs, such as, I think I mentioned, you have a person going out into the field to do calibrations in a static probe installation, correct? And it varies what that looks like from customer to customer. That could be as quick as, let's say, 15 minutes. And, we've got customers that have to take as much as maybe 45 minutes to do a proper calibration, because there's also typically a cleaning step that's involved there, of course, because you don't want to calibrate a dirty electrode. That's just going to cause the probe not to function properly. So what that leads to is, by going to an automated solution, which in this case, as I said, there's a program in the transmitter that signals on a regular basis the controller to, again, retract, clean, calibrate, then reinsert it back into the process without a technician or an individual being at the system. This happens on a daily basis, multiple times a day potentially. And other than just making sure that the buffer containers are full for calibration solutions, and when a sensor does reach end of life, someone goes out and does a replacement, the system can signal that. The benefit is that time that would have been spent on maybe not a daily basis, but certainly a weekly basis of a person having to babysit the static loop, that is all but almost eliminated, of course, by going to an automated solution. And just an additional comment on that, nowadays it's even harder to find people who want to work in this industry. I'm sure you've read articles where there's fewer and fewer people who want to work in these industrial environments. So there's ways to help benefit customers by, again, using this type of automation.
I think another thing we need to mention on is, as our sensors have the sensor face, that's will tell you the condition of your sensor. We also have a sensor face for the automated system. So it'll tell you your air pressure, if your water pressure is low, if your sensor is moving, stroking too slow or too fast. It'll tell you problems that may be coming up. It tells you the health of your automated system.
Exactly. And sometimes that's referred to, of course, as predictive maintenance as well. So, no one likes to come into the office in the morning and get their list of things that have to be taken care of and find out that a pH loop has already failed. So leveraging the data out of the system is a critical component to the automation, because not just are you doing the mechanical and physical maintenance of the sensor, we also want to understand, as Joe mentioned, what is the health of the sensor? Are we going to expect a potential end of life within a certain period of time? And in that way, you can go out and deal with it at a more opportune time than trying to deal with it once it's already happened. So I think this is one of the big developments with online and inline liquid analytics, is the ability to leverage the microprocessor, leverage the ability to understand what's going on with the sensor, and be able to take actions that'll help keep you up running longer, shorter interruptions in the process, which again benefits the cost of operation for the facility. And something I wanted to mention is also working in these environments. Now, again, it's not all environments, but let's say you're looking at a refinery, chemical plant, some of those types of locations. Area classification is critical. So I want to just point that out. For instance, in this case, our automated system, the C-Care, has FM approval. So from a safety standpoint, being able to operate in areas where flammable gases may exist, things of that nature, that is well within the capability of this type of system. it's not a problem. So I just want the audience to be aware of that, because if you're working in those types of process areas, you're like, well, that's all great, but I need FM. That is covered with this type of system. Yeah, go ahead.
I'm gonna say that, so I get calls, Ron, from folks who, mostly wastewater treatment plants, water treatment plants. They don't necessarily need the calibration. They don't need a full-blown system, you have here. What are the other options on a cleaning system that we can offer?
Sure, sure. So, Seth, I'm going to ask you to pull up the CL90 slide for me. Just give me a thumbs up once that is up so the audience can see it. Perfect. Thank you. So what you're looking at here is a system that Joe was alluding to, which is a cleaning only system. So this is just one example of where a customer may not require the level of sophistication that something like what's behind us would bring, where they're just trying to get ahead of the buildup that is accumulating on the pH probe. So if it's lime deposits, they're dosing into a water stream and they're trying to manage the pH, then we can retract that probe on a regular basis, get it clean before it builds up to a point where it just makes the probe inoperable. So it's a great solution. And if you could pop down to the next slide. And in this slide, you should see a couple of photographs of a typical installation. So this is, I believe, on a wastewater application, more in an industrial environment, but it applies both ways. So as you can see, you have the CL90 controller, which is similar to what we have here, except it's a clean-only type system. And it's using plant water typically as the cleaning agent. So they just bring in compressed water or water under pressure into the controller in the CL90. And then you'll notice there's a transmitter next to it, which again is where you have the ability to program the scheduler, which is a real nice user interface where you can program in the interval of how frequently you want to retract and then clean the probe and how long that wash cycle needs to last. And then when it does that, and this would apply to both the fully automated Cal and Clean and the CL90, is that we would clamp the 4-20 to make certain that the 4-20 is not moving around during this cleaning cycle. So it makes it transparent almost to the control system during the interval of this cleaning and calibration, if you're looking at the one behind me. Sometimes people ask, well, how long is that cycle? What does that look like? Am I offline for a half hour? Am I offline? And usually it's in minutes. So depending on how severe the buildup could be, you may need to clean for 30 seconds or maybe a minute, depending on the circumstances, but it is not, we're not talking tens of minutes at all. It is a very relatively short cycle to be offline and do these maintenance tasks through the automated system.
And I would imagine the Unical system is more costs more than the CL90. CL90 is a more cost-effective option for those who don't need the calibration system.
Absolutely. And of course, when you're adding things as additional pumps, of course, you're bringing in other consumables like calibration solutions. There's a level of sophistication that occurs here with this C-Care versus the more basic, although very effective if you're just looking at a cleaning solution or system, I should say, which is going to be at a lower cost. Now, one of the things is it does use and Seth, are we still in that picture or not? Okay. It still uses the retractable assembly. So that really doesn't change. There's some minor modifications, but you're still getting the benefit on the cleaning system of the retraction, isolation, the cleaning, and then reinsertion back into the process without interrupting the process flow through your process piping.
Let's so either system, let's take a moment and talk about operator safety. Either system will help improve operator safety.
Yeah, absolutely. Operator safety, I think everyone would agree that operator safety is paramount. It's probably without a doubt the most important thing. So keeping your personnel safe, reducing their exposure to harsh chemicals. I know I mentioned it a little bit earlier, but it's worth mentioning again. It's always a benefit to the company. It's always a benefit to mitigate those types of risks. You know, there's certain applications where you just don't want people to be around it. We've had customers come to us where they've got processes where they have to do the full suit, the Scott pack and everything. They're not that common, but they're out there, right? And we try to avoid those, having those types of processes if we can, but the ones that exist benefit greatly, again, to the automation. It's not that you never have to go out to that unit and manipulate the sensor, but you reduce the number of times and the time in the unit when you do have to go out there and deal with a pH a pH replacement or something that's going on with the assembly. Something I wanted to point out, and again, from a maintenance standpoint, automated systems maintain the pH probe, as we've already established, through either calibration and cleaning, but there's still maintenance that's required with the automated system itself, and that would be refilling calibration solutions and detergents and things like that. But just to give you an idea, usually under what I would call normal circumstances, most common circumstances, you'll get about 140 calibrations and cleaning cycles out of the system behind me. So just thinking about going out and maintaining that system, it's not a daily task. You're not out there constantly having to touch the system. Calibration, you can run probably a month to 3 months, depending on the interval of calibration, before someone physically has to go out and touch the system. That's just an example of what we've seen from our customers. So that feeds into cost savings, that feeds into safety, which are, again, two important things that customers are asking us about.
Yeah, I get a lot of calls from end users who really, they just want an automated system because of the operator safety issue.
Yeah, yeah.
And their guys are just tired of going out there and suiting up, getting their bucket, going out, good weather, bad weather, hot weather, cold weather. Our guys don't want to do it anymore.
Yeah,
And it's making the automated system worthwhile for them.
It really does become a more attractive solution. Now, of course, you go back, 10 years even, maybe even further, that automation has always been something to discuss within a process environment. Automation is a way to, as we already established, again, to save costs, to increase throughput, but bringing it back to that safety conversation, we've got many customers that see that, as we already discussed, as one of the biggest advantages. That aside, even for a second, thinking about the customers we deal with when we provide them and when they invest in an automated system, the feedback we get is, of course, the operators or the technicians themselves are not in the unit as frequently, of course, which is one of the benefits. But that person is able to now address other things within the plant that require maybe more immediate attention or can have additional impact on operational costs, where instead of going out, and this is no exaggeration, we do have customers that say we go out and have to clean that pH probe 3-5 times a day. So you've got somebody like in a sugar mill. This is not uncommon because the carbonation process, you get the line buildup around the electrode, and it happens within less than an hour sometimes. So you have to constantly pull that probe, clean it. When they go to an automated system, that, of course, is addressed already through the system. Those people, those technicians, whomever they are now able to go and save the company money in another process area that, as I said, might require more immediate attention, and are not connected to this to a static loop where they're constantly having to pull that probe, which leads to another benefit. And we never want to break something on purpose, right? But it happens accidentally. And what I'm getting to is, in processes where buildup occurs, and you go to try to pull that probe out of the process connection, and some in the audience probably know exactly what I'm going to say, it'll get stuck, right? And then sometimes, unfortunately, you might break that electrode, that glass pH electrode. Sometimes, if you're having a bad day, you set it on your toolbox or somewhere, and it rolls off and it hits the ground, and you break the bulb or something. That's because you're having to manually manipulate that electrode, which, again, coming back to automation, that is all being taken care of by the retractable assembly. You can stay ahead of that buildup so you don't get those situations where the probe cements into a static holder. And then, of course, now you've got to deal with replacing the probe, potentially the cable, other components just to get that loop back up and measuring pH.
So you're reducing costs by eliminating the operator error.
Yeah, exactly. Yeah, we never want to say that, people make mistakes, but I know I do. And if we can do things to help make the job easier where operator error can be reduced, because it's just a fact of life. If we can reduce the operator error, come back to say calibrations for a moment. Calibrations, benefit greatly from automation. And I already said, by getting a more precise calibration, you get a better product quality potentially. Also, the benefit is by having a better calibration, you reduce the number of interruptions in the process. So if you have interlocks that when the pH drifts out of range, you then have to take an action to correct that pH. Well, by having better calibrations that aren't being affected by human error, you can then potentially eliminate those trips, those deviation effects, those lockouts, because you have to address it, which we know, again, benefits from an operational efficiency and a cost aspect. What other questions do we have that we want to cover?
So on the product quality, then it's really the consistent measurement that you get from an automated system helps improve your product quality.
Yep, absolutely. Yeah. And there's another benefit, which is environmental compliance. So we don't want to forget about environmental compliance. It's not typically in the part of the plant that's a profit center, right? But it can also, if you're not compliant, it can really affect how you're operating and some of the issues that creep up from an environmental perspective. So from a compliance standpoint, reporting is critical, whether it be an air permit, whether it be a water permit, where you have to have the ability to collect the data that the probe was calibrated, it was calibrated correctly, and it was on this date, and then you can produce those records on demand. So coming back to an automated system, a really nice capability that's built in is recording those calibration reports. So then by recording that data and making sure those calibrations are always the same, you can then produce those reports to the authorities when they do show up eventually and say, hey, show us that you're doing what your permit says that you need to do. And this fills a gap there for a lot of customers that for one reason or another are having problems with that potentially. It's not that they don't want to do a good job. It's just for whatever reason, the circumstances or whatever the case is, this can really help in those situations. That might be our #1 application that we fill with a fully automated calibration and cleaning solution is when it comes to an environmental compliance standpoint.
Yeah, we see them on the outflow of plants.
Yep, absolutely. And it varies. Sorry, I didn't mean to cut you off, but it varies. It's steel mills, pharmaceutical plants, chemical, petrochemical, refining, essentially any plant that has any effluent going to a creek, a lake, a river, whatever it is, they're going to have to satisfy a water permit. And again, there's a lot of people out there that use this technology.
Even without the permit requirement, we're seeing a lot of people just ask about automated systems because of the sustainability issue.
Yeah.
Right. That's the catchword nowadays, and everybody's worried about sustainability.
Exactly. And sustainability can probably look different for different customers. Sustainability can look like I have to treat this effluent stream, and I have to treat it with a certain chemical to neutralize it, and I have to add this to it to make sure that when it leaves my facility, it's compliant, correct? But you don't want to overdose. You don't want to waste the chemicals that you have to use. You don't want to do more than you really need to, because that can actually set up problems downstream by overdosing or using too much. So yeah, from a conservation, a sustainability standpoint, the automated system really helps kind of rein in those types of situations, and it gives you confidence that you're only using what you need to satisfy the requirement of the process conditions, and subsequently you're doing your part to conserve those chemicals and not putting them out into the environment, which of course is the goal is not to. We've talked about lifespan of sensors. We talked about, we talked about the personnel safety. Another thing I want to touch on is, I already mentioned reporting, but reporting in the pharmaceutical environment, because this is something that's really important. So when anything's done to the system, calibrations, recording of the calibrations, maintenance to the system, anything that the FDA wants to know about, there's the ability to retain that information, the CFR 21 Part 11 format, which is an unalterable report, so that that can be used to, again, satisfy the authorities who come in, and it's their job to verify that you're doing things the way you need to satisfy the industry standard and to make sure that your end product is safe, of course. So I just want to point that out as well. Joe mentioned this system is actually an example of a system we use in the pharmaceutical industry. So sanitary connection, you can bring in steam for SIP, you can bring in caustic for a clean in place. All that happens inside this retractable assembly and maintains the hygienic requirement for those types of measurements. So for anyone in the audience that has struggled potentially in that industry with those types of challenges related to those cleaning cycles where contamination may be something that you're trying to get your arms around a little bit, this is something that can certainly help. And we've got many customers in that industry that benefit from just the cleaning ability of the actual retractable assembly by way of an automated system.
Yeah, as Ron was talking about the data recording, anytime someone touches the transmitter, hits a button on the transmitter, that'll be recorded. Anytime the probe is inserted or retracted, all that activity is recorded. And the transmitter also has 3 levels of password protection.
Yep.
So you could set it up for an operator can only, do these functions, and then somewhere farther down the line, more of a management type, they have access to a lot more other functions, programming, and that type of thing. So the transmitters also sort of a safety device.
Yeah, absolutely. Absolutely. And, coming back to, where we kind of started, automation is not for every application. So by no means are we saying if you have a static pH loop, you should put an automated system on it. Would companies like ourselves like to see that? Sure, we would. But that's not realistic. That's not what we're advocating. But those of you in the audience are probably thinking about potentially, well, I do know those one or two, maybe 3 applications where we could benefit from automation. And then you think about the balance of your installations from a pH standpoint. You think, oh, no, we have a pretty good handle on the maintenance side of it. And automation wouldn't really bring a lot of benefit, but it's those few that can really have a serious impact on the topics we covered, the cost, the safety, the environmental compliance, things of that nature. And something else I want to mention, we focused on pH in this webinar and how it benefits from automation. We can also automate from a cleaning perspective, dissolved oxygen, ORP, conductivity. So if you have those applications where you're thinking, well, my problem from a cleaning standpoint, not calibration necessarily, but a cleaning standpoint on those other measurements, we can also help in those cases. So we do have many customers that have those other analytical in-process online type measurements that just get gummed up due to catalyst in the process, resins, whatever might be going through the pipe. Clearly, if it touches the electrode, it's going to eventually build up. We can provide you a way to keep ahead of that so that the probe can measure correctly and not drift because the bulb and junction are coated by some type of debris. So, Seth, any questions that have come through that we? Excellent. So Seth just told us someone in the audience asked how to retrieve calibration reports. So there's really 2 ways to do that. Both on the system you see here in the CL90 with the Stratus Multi that was displayed, you can go by way of a removable memory card that is plugged into the transmitter, which you can set up to store those calibration reports. Then you would remove it, take it to your office, take it to a laptop, whatever, plug it in, and then upload those to your laptop through a piece of free software that we provide. So that's one way. The second way would be if you have a digital connection from the transmitter, that could be Profinet, Ethernet IP, Field Bus, all those are available on most, if not all, the transmitters. You can then retrieve it that way as well. So that would require integration into your into your PLC or DCS, but it's definitely doable. And you can, matter of fact, you can control this system remotely in those cases as well. I know I've answered the first question, but made me think about remote control of the system. So that's becoming more important and attractive to customers, being able to not just retrieve the data, which the data these days is becoming almost as important as the measurement itself, right? Of course, the measurement has to work, but be able to get the data, as we discussed, is very critical. We give you the ability to have more control remotely, which many customers do this, and it just gives them the ability to have, let's say, visibility, because this is an investment, and they want to make sure their investment's paying off for them, and they want to know when something is happening that they need to address.
Yeah, and I would say with that, just when you're looking for me to quote, just let me know if you need Hirth or Profibus or Ethernet connection, anything like that. We can specify the correct transmitter.
Exactly. Seth, what else do we have here? So the question was, is it possible not to freeze the output, I believe is what we're talking about when you do calibration of a pH probe. Hopefully I got that correct. So I'm going to answer it as best as I can. So as I think about when I do a calibration, whether it's an automated calibration or it's an automated cleaning, either it applies to both, the system recognizes when the program activates. So it knows that it's about to retract the electrode. So before it retracts, it puts the output into hold. So once it's in hold, then it retracts the electrode. Then it's going to conduct the cleaning and calibration if that type of system, or if it's just cleaning. It'll go through the cycle, and it'll then reinsert the probe back into process, and it's going to let the sensor acclimate to the process for a little bit. And those are fully adjustable parameters. So you can make that 15 seconds, you can make it 45 seconds, whatever you require for your process. Once it's acclimated, the program will release that output, and then you're back to an active signal. So I hope that answers the question correctly. So if I didn't, please re-ask it, and then I'll clarify if needed.
And there's options for while that's going on. You can set it up for the last recordable value will display on your screen.
Absolutely, yeah. Last recordable value, you can have it default to a given value. Really, as Joe's saying, it's selectable and customizable for the customer.
And then one thing we didn't really touch on is the service switch is a bypass. So you can put the system in service, and it'll halt any program at that point, and then the operator can do a manual check, let's say, of the probe if he'd like to, a variety of reasons that you would want to get into the service mode and then get back into the process. It's a manual override.
Yeah, absolutely. Both here on the calibration and cleaning version and on the CL90 we saw earlier, both have a way to manually or to retract the probe and to make sure you have the ability to gain access to it. And you don't even have to touch the front of the transmitter. This is all done, as he said, through a service program or through a automated switch where you can retract and then do a manual cleaning or remove the sensor from the holder. So any other questions, please feel free to go ahead and type those in. We're more than happy to answer those. We could go on for a lot longer, but we want to give folks who may have a question that they want to get into the queue that we go ahead and take care of it. So what we'll do is we'll sit here for a few moments. We'll probably talk a little bit more here about different aspects of the system, and then Seth will let us know if there's any more questions that come through. And it looks like there might be here. So the question was, so during the calibration, the output is on hold, and that's correct. So just to reiterate, when we go into a calibration and we retract that electrode, before retraction, we clamp the 4 to 20. It is not moving. It's set to either a predetermined value or the last value prior to retraction. So, and it's going to freeze at that point, and then it's going to conduct the cleaning, the calibration, and then put it back in process. And then, as I said, you equalize or normalize it to your process for a few moments, then it's going to release or unfreeze the 4 to 20 or whatever the output is, to make sure that you don't see this fluctuation during that maintenance of either calibration or cleaning. But very good question. So again, as I said, we'll stay here for a little bit and answer any additional questions. I'm just going to see what else might be of interest from a question standpoint here. Yeah, I think we've covered a lot of the major topics. Again, just to kind of put a final few minutes in the webinar, automation is a great way to, again, reduce the cost, increase the safety, definitely impact your product quality in those applications where that precision is required from a calibration standpoint. And again, that can have a huge impact on our customers. And then from a environmental compliance and sustainability standpoint, again, one of the things, I don't know if we really mentioned it, on static measurements, one of the complaints, if you will, is when a technician goes out to do a 2-point or 3-point calibration on a static pH on a pipe, they'll take a big bottle of pH buffer with them, right? They'll put it in their buggy and they'll roll out to the pipe, and then they'll have another cup that they'll transfer a bunch of liquid to, and then they'll probably have 2 cups of that, and then they'll do one calibration, and then that all gets poured out. So, again, one of the things to think about when you look at automating that particular step, that calibration, only the volume of calibration solution that you need to accomplish that calibration is used. So from a conservation standpoint, that goes back into cost of ownership and reduced costs, is that you now aren't going to consume, and I'm not saying people in the audience do this, but we've seen it, and customers have said, hey, we'd really like to stop buying a bunch of calibration buffer. That can definitely help in those situations as well.
Want to touch on Prezi before we head out?
Yeah, that's a great point. Are we
for more information?
Yeah, so for anyone in the audience that is interested in knowing more beyond this webinar, we're more than happy. Please feel free to reach out to us. We have a way to present our automated systems. It's not a PowerPoint per se, it's more of an interactive presentation. It goes deep into the technical that we really haven't covered here. Wasn't the purpose of this webinar, but we go into the very technical of each of the systems, both the CL90, the C-Care system, and we're more than happy to schedule time with anyone who's interested in knowing more about it. And we can share that information, and it'd be our pleasure to do that for anyone that is interested.
A very powerful tool. Yeah.
All right. Well, thank you, everyone. Really appreciate the time. Hopefully this was informative. And again, reach out to us if you have any further questions. Thank you very much.
Yep.